My name is Mamad Baby Soumya. Here I'm going to present my seminar video on thunderstorm and lightning prediction using machine learning as a part of machine learning for Earth System Sciences course. What is a thunderstorm and lightning course? When does they occur? A thunderstorm or is a convective storm is a cumulonimbus cloud that produces the electric discharge known as lightning, which produces thunder and typically generates heavy rainfall, gusty surface wind, and possibly hail. As the storm moves over the ground, the strong negative charge in the cloud attracts positive charges, and this causes lightning. Cumulonimbus clouds can reach heights of thousands of feet, so they bring thunder, lightning, and in worst case, they also cause tornadoes. What is the intensity of thunderstorm? The greater the instability of air, the more readily and quickly air rises, determining thunderstorm intensity. We can measure this instability using CAPE, uh, which means convective available potential energy. The greater the levels of heat and humidity, the higher the amount of CAPE. Though the CAPE alone cannot assure the presence of a thunderstorm. It's simply a measurement of how catastrophic a thunderstorm could be. What are the hazards? Like lightning is responsible for so much for human injuries and fatalities, death of livestock, forest fires, and the electromagnetic interference can also cause so many uh, electric appliances damaged. It also major source of electromagnetic interference, and it causes damage to buildings and other exposed man-made structures. Lightning and thunderstorms can cause several billions of euros worth damage and loss of life on a yearly basis. GCMs and RCMs are known to suffer from many unrealistic aspects in this simulated convection. GCMs means global climate models and RCMs are regional climate models. How we use ML for predicting these thunderstorms and lightning. Defects in convective parameterizing models and unpredictability in storm initiation make thunderstorm prediction difficult. So it is very difficult to predict the thunderstorms. Despite significant attempts using the theoretical frameworks, convective parameterization has made only a limited progress. Convective weather records are typically spatially or temporally constrained. What are our objectives? Our objectives are to investigate the atmospheric reanalysis data to predict the occurrence of lightning and thunderstorms. And in order to train classifiers with lightning data, researchers used logistic regression, random forest, gradient boost, decision trees, etc. to forecast the thunderstorm occurrence in various regions. We are using the data which is already present. We used reanalysis and lightning data from European domains. For convectively active season, that is in the years from the season May to August, we consider the years 2012 to 17 and high quality lightning location networks. In order to explore variations, we also consider some other data with high latitude convection. uh, Data from a tropical domain, that is Sri Lanka, is also collected. How do we pre-process the data? The predictor we used is that if at least one lightning flash was observed within 28 into 28 kilometer grid cells within 45 minutes, the class is labeled thundery. Predictors. To decrease redundancy, a set of 40 convective variables such as CAP, CAPE, relative humidity, etc. were also considered as thunderstorm predictors from a pool of 60 variables. Undersampling the null cases reduced the class imbalance, with the majority being null cases with no lightning. Classifiers. We use 3 classifiers for this process. They are logistic regression, decision trees, and neural networks. What is a logistic regression? It often performs well on nonlinear problems such as convection. Logistic regression outperformed RFs in distribution between lightning and non-lightning days in predicting small-scale convective initiation from numerical weather prediction model. Logistic regression training and optimization. How do we train this model? All the 40 input feature variables are used for training. Separate logistic regression models were fitted to the training data from Europe and Sri Lanka. The optimization we made here is the lasso regression. Due to a large number of predictors, the lasso regularization method was used with logistic regression to constrain the models to use an optimal subset of predictors. And the second one we used here is decision trees. As a we see two here, like they are random forest. Decision trees are trained independently with each tree using a different subset of data. And in boosted decision trees, boosting is an ensemble strategy for training models successively, with each model aiming to reduce the prior model's prediction errors. In this picture, we can see the demonstration of random forest methodology. Random forest training and optimization. All 40 inputs were used. The most important hyperparameter is the maximum depth of the trees. And the fully grown trees are used as restricting the tree depth degraded performance. Drawback. The drawback here is that because of enormous tree depth and more size, a lot of memory is required. The future importance in the random forest training is CAPE and lifted index in Europe, soil temperature in Sri Lanka. Boosted decision trees training and optimization. In this second method, we use the model hyperparameters were tuned using Bayesian optimization with a Gaussian process. The improved model was then used to perform recursive feature selection to remove redundant features from the 40 starting features. Feature selection. The correlation matrix is used to remove redundant features, while LGPM is used to investigate the impact of deleting factors with the low relevance or strong correlation. Future transformations were done which improved the performance. And second, we use the neural networks are mapped to outputs by one or more layer of nodes connected to each other by nonlinear functions with adjustable performance parameters. This is the third method we are using. The aim is to find a set of weights which minimize the measure of difference between NN neural network output and training labels. The loss functions used are RMSE and cross entropy classification. In neural network training, all the input was converted to range 0 and 1, and then we use feed forward neural networks for predicting thunderstorm, testing both shallow and deep neural networks, trained using the reduced feature set from boosted decision trees and Bayesian optimization to tune the model architecture. As a global model, data from Europe and Sri Lanka were pooled together and NNs were trained to predict thunderstorm occurrence. The performance was slightly worse from Europe but higher in Sri Lanka compared to models trained separately before. After using the three models, the evaluation is, along with ML classifiers, three typical convective trigger methods are included. They are regular CAPE, diluted CAPE. Among the traditional parameters, regular CAPE performs relatively well in Europe but not in Sri Lanka, and diluted CAPE has poor performance everywhere. Overall, the models perform very well in Europe and also in Sri Lanka, where convective indices did not. The relationship between undiluted CAPE and TO was very weak in the region. Regarding the choice of model, we note that decision tree ensembles were able to offer similar performance to the dependents, probably due to successful future engineering. Here we can see the results, a summary of model skill, area under precision, and we can see the CAPE, all the models here. What are the factors regulating deep convection? Humidity in the low to middle troposphere controls tropical convection, especially over sea. These are the environmental factors that are affecting the deep convection. Even in Europe, moisture and humidity in the low to middle troposphere were important thunderstorm forecasters. Estimates of future changes in convective storms must take into account storm as well as changes in conditional instability. The conclusion is that machine learning models may forecast thunderstorm occurrence with far more accuracy than traditional parameters. The optimum parameters for predicting thunderstorms vary by region, but if trained on them, neural networks functions well across the climates. These are the references used. Thank you.